Okay, in this video, we're just going to finish up chapter 2 from our textbook and just cover elasticity in this video. All right, here we go. So elasticity generally is measuring the responsiveness of one value relative to the change in another value. And so since you guys have already covered this in Econ 201, we're going to go through it again quickly with a little more depth. But this should mostly be review. Just a reminder, we're going to look at a couple of different elasticities. So we're going to cover elasticity of demand, elasticity of supply, income elasticity of demand, and cross-price elasticity of demand. So let's start with elasticity of demand and elasticity of supply. So the percentage change in quantity demanded that results from a 1% change in price is what we call elasticity of demand. And it can be written like this. So the elasticity of demand is equal to the percentage change. So this delta here is change in quantity demanded, QD, divided by the percentage change in price on the bottom. And then similarly, supply for elasticity of supply, percent change in quantity supplied that results from a 1% change in price. That's what we call elasticity of supply. And it can be written basically in the same form as the elasticity of demand, except for we're substituting quantity supplied in for quantity demanded, obviously. Okay, so let's take a look at an example since we already have the formula for elasticity. So what is the price elasticity of demand if quantity demanded falls by 3% after a 10% price increase? So let me grab a pen here. So elasticity of demand is equal to the percent change in quantity demanded divided by the percent change in price. So that's just the formula from the last slide. And we can just take these two pieces of information and solve for elasticity of demand. So our percent change in quantity demanded, the question just tells us that it's that quantity demanded falls by 3%. So that's -3. And on the bottom here, we have a 10% price increase. So that will be 10. So our elasticity of demand is -3 over 10, or -0.3. And because demand curves slope downward, we should always get a negative elasticity for demand in general. And then, sometimes elasticity of demand is written in terms of absolute value. So that would be the case if you see a positive elasticity of demand. Okay, so here's another example. What is the price elasticity of supply if quantity supplied increases by 9% after a 6% price increase? So again, elasticity of supply is just percent change in quantity supplied, QS, divided by the percentage change in price. So again, we can just take the two pieces of information we need from the question, plug those into our formula and solve. So elasticity of supply is going to be equal to the 9% increase in quantity supplied, so 9 on top, divided by the 6% price increase, so 6 there. 9 over 6 is going to be 1.5. So our elasticity of supply is equal to 1.5. And we know that supply curves slope upward. So because of the law of supply, so we should get positive elasticities for our elasticity of supply. Okay, so we can also think about elasticities graphically. So we'll do this for demand and supply curves, even though it's basically going to be the same thing. So the steepness of the demand curve in this case is going to tell us something about the elasticity of demand, basically. So inelastic demand curves have steep slopes. So this curve is inelastic. And we know this because the curve is steep. The slope is steep. And basically, this is telling us that the quantity demanded is relatively unresponsive to a change in price. And I'll show this relative to the elastic demand curve, which is much flatter. And so let's take a baseline price right here. Hopefully I drew a straight line, and look at the same change in price. So I'm going to decrease the price down just a little bit to here on both graphs. And what we can notice is that for the inelastic demand curve, the quantity demanded doesn't change by a lot. But for the elastic demand curve, we have a really large change in quantity demanded. And that's basically the difference here between the inelastic and the elastic demand curve. The elastic demand curve is going to be a lot more responsive to changes in price. And now, like I said, similarly, we can look at this for supply. The only real difference here is that supply curves are going to slope upward. But again, a steeper slope is going to indicate an inelastic supply curve, and then a flatter slope is going to indicate an elastic supply curve. And I'll go through the same little exercise here. I'm going to pick just this price here on both supply curves, and then we will increase the price to a new price and see how that affects our quantity supplied. Again, with the inelastic supply curve, we see very little change in the quantity supplied, whereas in the elastic supply curve, we see a large change in the quantity supplied. So again, that's the difference. Elastic is much more responsive to price, inelastic not so responsive to price. Okay, so let's come back to some mathematical notation for elasticities. So just looking at elasticity of demand here, again, we can write elasticity of demand in a number of ways. We know that it's percentage change in quantity demanded divided by the percent change in price. Another way to write this is the change in QD over Q, the quantity, over the change in price over price. And then I'm going to rewrite this in one more way. So change in QD, to make it more clear what's going on at the bottom here, over the change in price times price over our QD. And I'll throw the D's in here as well. Now, we also know that slope is just rise over run, right? So we remember slope is rise over run. Write that over here. Slope equals rise over run, right? Rise over run. And we remember what this means. This is what I learned when I was in algebra. Rise was on the y-axis and run was on the x-axis. So we had our change in y over change in x. Now with our demand and supply framework, our y variable on the horizontal axis is our price, right? So the slope in this case is just change in price over change in quantity, because quantity is on the x, price is on the y, right? And so this looks an awful lot like this, only backwards, right? So 1 over the slope is just equal to the reciprocal of this, so change in quantity over change in price, right? And so that's exactly that term there. So we could substitute the slope in here, or 1 over the slope in there, and we get this term here at the bottom. So elasticity of demand is equal to 1 over the slope times price over quantity, right? And so this is going to be useful because now we can take slope with a price and quantity and figure out what elasticity of demand is. And so let's look at an example here. So I'm going to write out our new formula for elasticity of demand right here so that we don't forget it. 1 over the slope times price over quantity, right? And so this question is giving us a demand curve. P equals 10 minus 3Q. And it wants us to find the elasticity of demand when our price is 4. So the first thing we need well, we can find three pieces of information that will give us the elasticity of demand. So we're going to know the slope already because we can just take the slope directly from this demand equation. So we know that's going to be -3. So we can start filling in our formula here. Elasticity of demand is equal to 1/-3 times our price, which it gives us, which is 4. And then we're left with this unknown quantity. So we're going to need to figure out what the quantity demanded is at this price. And the easiest way to do that is just plug in price to the demand equation and find out what quantity is. So if price is 4, we can just write 4 is equal to 10 minus 3q. And so we can go through the math, subtract 10 on both sides, gives us -6 is equal to -3q. And then if we divide -3 on both sides, we'll get that q is equal to 2. So now that we found q is equal to 2, we can plug that quantity into our equation. And so now we have all the missing terms filled in, and we can just solve for elasticity of demand. So we have -1/3 times 4/2, which is just going to be 2. And that's going to give us -2/3 or -0.666, repeating. So using the demand curve, really just the slope, and a price and quantity, we can find the elasticity of demand at the price of 4. Okay, so let's talk about the relationship between revenue and elasticity, because they're connected in an interesting way here. So we know that revenue is just price times quantity, right? So it's the number of units you sell times the price you're selling each unit at. And so we know from the law of demand that increasing a price will decrease quantity demanded, but we don't know about how much, right? So that's what elasticity is telling us, how much demand is changing in response to a price change. And so we don't really know. We want to know how a price change is going to affect our revenue, given that it's not only affecting the price, it's also going to affect how many units we're selling, right? So basically the rule here is if the price increase is greater than the demand decrease that results from the price increase, then this will increase our revenue, right? It'll be good for our revenue. And of course, these need to be in percentage terms, right? So in other words, if the percentage change in price, the percentage change in increase of a price is greater than the percentage change decrease in quantity demanded, then that's going to be good for us. We're going to increase our revenue. Okay, so remember, elasticity of demand, again, is just percent change in quantity demanded over percent change in price. So we can use this formula to see what elasticities are or how each elasticity affects our revenue, basically. So if our percentage change in quantity demanded in absolute value is equal to our percent change in price, this means that elasticity of demand is going to be -1. And you can see that because the percent change in quantity demanded, which will be negative, if that's equal to percent change in price, so say we have -3/3, that will just give us -1. So that's going to leave our revenue unaffected because the change in quantity demanded is equal to the magnitude of the change in quantity in price. We could also have the change in quantity demanded being greater than the change in price, than the percent change in price. And this is when elasticity is less than -1. And this is going to be a scenario that decreases our total revenue because we're losing more unit sales than we're gaining from, we're losing more in revenue from the loss of quantity of sales than we are from gaining on each on the price increase on each unit of sales, right? So again, if our change in quantity is greater than the percent change in price, that change in price is going to be decreasing our revenue. And then finally, if our percent change in quantity demanded is less than the percent change in price, then that will increase our revenue. So that's kind of our rule up here. And then this is where our elasticity of demand is greater than -1. So between 0 and -1. Okay, so just to classify elasticities here real quick, we say that elasticities in absolute value, if they're equal to 1, we call that unit elastic. If they're less than 1 in absolute value, that's oh, actually I have these backwards, don't I? This is inelastic. And then of course, if they're greater than 1 in absolute value, that would be elastic. Sorry about that. And so remember, basically, elastic is telling us that our responsiveness is very responsive to some change. Inelastic is not so responsive to a change. So the larger number in absolute value is telling us that the change in response to some other change is large. And so that's why that's elastic, and why negative or less than 1 is inelastic. Okay, so we can also talk about other types of elasticities. So one of those types of elasticities is income elasticity. So basically, this is just the responsiveness of quantity demanded to a change in income. Right. So we might think, if people's income rises, what happens to the demand for certain goods? And so we can write the income elasticity of demand is equal to the percent change in quantity demanded divided by the percent change in income. Now this looks an awful lot like the price elasticity of demand, but instead of price, we just kind of insert income into the equation. So we could again write this as change in quantity demanded over change in income times income over quantity demanded. And so with income elasticity, we can classify goods based on what their elasticity is. So we have normal goods, which you'll remember from 201 is if our income goes up, so does our quantity demanded for that good. That's a Q. Inferior goods are the opposite. If our income goes up, quantity demanded will go down. And then luxury goods are goods where the income elasticity is greater than 1. So if our income rises, demand for that good is rising by a lot. Yeah, and so an example of a normal good is like pizza or computers or cars. If your income rises, you'll buy more pizza or things like that. Inferior goods may be things like ramen noodles, where if your income rises to the point where you no longer have to eat ramen noodles, you can afford more expensive, higher quality food, then you do so and you eat less ramen. And then luxury goods are exactly how they sound, yachts, things like that, where income rising really, really increases the amount of that good demanded. So we can do an example with income elasticity of demand. And so suppose incomes rise by 5%, and as a result, demand for apples increase by 1%. So we can find the elasticity of demand here, and then classify apples as a normal, inferior, or a luxury good. So remember, elasticity of demand, income elasticity of demand is going to be equal to the percent change in quantity demanded over our percent change in income, right? And so we're given both of these pieces of information again in the question. So incomes rise by 5%. So on the bottom we have 5, and on the top we have 1. And so our elasticity of demand here, our income elasticity of demand here is just going to be 1/5 or 0.2. And so because this good is, or the elasticity of demand for this good, for apples, is greater than 0, this must be a normal good. But because it is less than 1, we know that it's not a luxury good. So apples, in this case, are just a normal good. Okay, so we can also do what's called cross-price elasticity of demand. So goods can be related to each other. They can either be substitutes or complements. And that means that when we change the price of a complementary good, that will change the quantity demanded of that good's complement. So we're interested in the responsiveness of quantity demanded to a change in price of a related good. So we can write this as the elasticity of demand for good I relative to good J is equal to the percent change in quantity demanded of good I over the percent change in price of good J. So in this case, I'm going to say I is going to be, let's say, peanut butter, and J will be jelly, just so that we have two goods to think about, and we can maybe visualize that or something. And so we could, again, write this as change in quantity for good I, so change in quantity demanded of peanut butter over the change in price of jelly times the price of jelly over the quantity demanded of peanut butter. And so we're going to get an elasticity that's either greater than 0 or less than 0, and that will allow us to determine whether the goods are substitutes or complements. So substitutes are goods that can be interchanged between one or the other. So substitutes is the one I always think of is Coke and Pepsi. Right? These are both types of colas. So, you know, typically people that drink one or the other will also drink the other. And so if the price of one substitute goes up, people will switch and buy the other good. So a price increase in Coke, so if the price of Coke goes up, that will increase the quantity in Pepsi. And so that's why the elasticity of demand between Coke and Pepsi will be, or the cross price elasticity of demand for Coke and Pepsi is going to be positive because they are substitutes. Because if we raise the price of one, that's going to increase the quantity demanded for the other because people will switch over. Now complements, I like to pick peanut butter and jelly. Those are, you know, the two things you put together for a peanut butter and jelly sandwich. And these are goods where if you raise the price of one, so we're changing the price of jelly, so the price goes up, what happens to the quantity of peanut butter? So our quantity of peanut butter is going to go down, or our elasticity is going to be negative. Because these are complements, if you're buying less jelly because the price goes up, that's just the law of demand, then you'll also buy less peanut butter because you're using them together, you're consuming them at the same time. So that's what complements are. So basically, knowing this fact about cross-price elasticity of demand will allow us to classify goods as complements or substitutes, or unrelated goods. If we find an elasticity where, or a cross-price elasticity that's 0, that means that those goods are neither complements nor substitutes, so they should be unrelated goods. Okay, so let's just do an example. Again, cross-price elasticity is elasticity of demand for good I relative to good J is equal to the percent change in quantity demanded for good I over the percent change in price of good J. And so those two pieces of information are going to be given to us in the question. So suppose the price of popcorn rises by 20%, and as a result, the quantity demanded for movie tickets decreases by 15%. So we know the quantity demanded is decreasing by 15%. So that's negative 15 over 20, which was the price increase of popcorn. So our elasticity is going to be negative 15 over 20, or negative 0.75. And since this elasticity is negative, we know that these goods are complements, although you could also kind of read into the problem that because people buy popcorn for movies when they go to the movie theater, they should be complements because the goods are being consumed together. So this is complements. But you could also look mathematically at the question and see that the elasticity is negative, so they must be complements. Okay, and I think this is where I end this video. In the next video, we'll start covering chapter 3. And